Number 11, b is equal to 2.35 plus 0.25x. C is equal to 1.75 plus 0.40x. In the equations above, B and C represent the price per pound in dollars of beef and chicken, respectively, X weeks after July 1st during last summer. What was the price per pound of beef when it was equal to the price per pound of chicken? All right, you guys realize this is a long question. Please just focus on whatever you need to focus on, right? Take a look. What does it say? What was price per pound of beef? So you're looking for the beef price, aka you're looking for this B over here, when it was equal to the price per pound of chicken. So B was equal to chicken. That's all you really have to focus then. B was equal to chicken at some point, and you are trying to look for the price per pound of beef when it was equal, right? So you have this. Go ahead and start your problem, right? You know what B is. B is 2.35 plus 0.25x. And you know what C is. C is 1.75 plus 0.40x, right? Go ahead and solve for the x, right? What is x? X weeks after July 1st, so x is weeks, right? Number of weeks. So subtract 0.25x on both sides. Then I get 2.35 is equal to 1.75 plus 0.15x. Subtract 1.75 on both sides. I get 0.60 is equal to 0.15x. Now, people hate dealing with decimals, right? And so do I. I mean, everybody hates decimals, right? So what do I want to do? Just move them over. I'm going to move 2 over here, so I'm going to also move 2 over here, right? Then I get 60 is equal to 15x, right? Oh, much better to work with. Divide by 15 on both sides, x is equal to 4. Now, this is where everybody stops normally, right? You just got lucky that 4 is not one of your answer choices, because if it was, everybody's going to go for that answer. Oh, I got x. X is equal to 4. I'm going to circle the 4, right? Once again, x is number of weeks, right? So, what is it asking? What was the price per pound of beef, right? So we are looking for the beef price. So now we got the x. Plug it back in to the B equation, right? So B is equal to 2.35 plus 0.25x, which is 4. Hey, 0.25 times 4? Come on, guys. 4 quarters. How much is that? $1, right? So 2.35 plus $1, which is equal to $3.35, right? Which is my answer choice D. Number 12, a line in the xy plane passes through the origin and has a slope of 1/7. Which of the following points lies on the plane? All right, once again, this type of a problem could be either a 2-minute problem or a 2-second problem. I'll first show you the long way and show you how it becomes a 2-second problem. So let's take a look at this problem and try to kind of guesstimate the line here, right? So the line passes through the origin. So let's just draw the graphing coordinate, something like this. And then 1, 2, 3, 4, 5, 6, 7, 2, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. Okay. All right. So they say it passes through the origin. So let me use a different color marker. So it has to go through that point. And then it's got a slope of 1/7. Okay, what is slope again? Slope is rise over run, right? You guys all remember that? Slope is rise over run, right? So let's look at it. The rise is 1 and the run is 7. So let's just do that on the graphing coordinate. Rise, so 1, and run. 1, 2, 3, 4, 5, 6, 7. Like that, right? And then my line has to go through these 2 points. So my line's going to look something like this. Super flat. And I could have guessed that because, I mean, slope, right? It is rise over run in terms of mathematical language, but just English literature speaking, slope literally means how steep something is, right? And they're saying the line is 1/7 steep, aka it's probably not even that steep. Super flat, right? 1/7, that's a small number, right? So if the slope is 1/7, it's probably a flat line, as we can tell over here, right? Okay, and we're looking for which of the following points lies on the plane. All right, so let's kind of guesstimate all these points by looking at our graph over here. 0, 7. 0, 7 is like right there. Clearly, it doesn't pass through that. So I'm going to cross that out. Oh, I'm sorry, 0, 7, that's over here. 0, 7. Well, yeah, that's definitely off, right? It's never going to pass that, right? So 0, 7, that's definitely off. So out anyway. 1/7, 1 and 7. So that's 1 and 7, that right there. It's not going to pass through that for sure. So that's also out. 7 and 7, that's right there. It's not going to pass through that. 14 and 2, where would that be? Well, this is 7 over here. That's 1 over here. So 14 would be something like over here, and 2 is like right there. So would it pass kind of, if it continues on? Possibly. So my answer is probably D. Now, did I really have to draw this graph to find out the answer for this problem? Probably not, because otherwise it wouldn't be a 2-second problem, right? How would this be a 2-second problem? Well, take a look. If you just knew the slope is rise over run, and the fact that you got 1 rise over 7 run, aka every time you go up 1 in the y unit, so 1 unit for y, you're moving 7 units on the x, right? So if you move 2 units for the y, it's probably moving 14 units on the x, right? So if you just take a look, don't even worry about the actual detail of the number. It's just the fact that every time you go up just a slight bit of an amount on the y-axis, you're moving a lot on the x-axis, aka your x is going to be much considerably bigger compared to your y value. Take a look at your answer choices. Look at A. Y is bigger than x. We just said it's got to be much more x than y, right? That's clearly not following the trend. Out. 1 and 7, once again, x has to be considerably bigger than the y. B's out. 7 and 7, once again, that's not bigger. They're the same. Look at D. 14 and 2. X is 14 and y is 2. X is much considerably bigger than the y, which is the only choice that actually makes sense. Looking at that, the slope is 1/7. Rise is 1, run is 7. So please, the next time you look at a problem something like this, don't draw the whole graph. If you understand this principle, you can answer this question in 2 seconds. Number 13. If x is greater than 3, which of the following is equivalent to 1 over x plus 2 plus 1 over x plus 3? Okay, I'm going to look at my answer choices. And clearly, I do not have anything like fraction over fraction, right? So we got to take care of that, which means for sure, these guys got to go, right? Because that's fraction over fraction, right? And they have to go, which means I got to multiply by something to cancel out the denominators on the bottom, which probably is, I'm going to multiply by the same thing, x plus 2 and x plus 3, in order to cancel out those on the bottom, right? So let's do that. 1 over x plus 2 plus 1 over x plus 3. Once again, like I just said, I'm going to multiply by x plus 2 so that I get rid of this guy, and then I'm multiply by x plus 3 so that I get rid of this guy. Why am I doing this? Once again, because I'm looking at my answer choices. I don't see any fraction over fraction, which means I know for sure I got to get rid of these guys. And that's why I'm multiplying by the same thing so I can cancel those out. And obviously, I can't just multiply stuff on the bottom. I got to do it on the top too. X plus 2 and x plus 3 over here. What's going to happen? Well, for this guy, it'll cancel out this way. Let me use a different color marker. So for this guy, it'll cancel out this way, and it'll be multiplied by 1 times x plus 3. So x plus 3 here. And then for this guy, x plus 3 and x plus 3, when I multiply, they'll cancel. And then it'll be 1 times x plus 2. So it's just going to be x plus 2 here, right? So that's what's going to be on the bottom. You guys see that? So on the bottom, I'll have this. So on my fraction, I'll have x plus 3 plus x plus 2 on the bottom, right? And then on the top, what do I have? 1 times all this, right? So x plus 2 times x plus 3. Now I'm going to stop here. and not continue for the rest of the problem. Because, once again, don't waste your time if you don't have to. This is a timed test, right? What's going to be on the bottom? X plus x, that's 2x. 3 plus 2, that's 5. So 2x plus 5 should be on the bottom, right? I'm going to look for that in my answer choices. Is that the case? Nope. 2x plus 5 is on the top, out. 2x plus 5 is on the bottom, I like that. 2x plus 5, but no other fraction, that means it's on the top, out. It doesn't even have 2x plus 5, out. My answer choice should be B. I mean, it's not that hard. X plus 2 times x plus 3. All you have to do is just FOIL, and it's going to be x squared plus 5x plus 6, which matches my answer choice. But I'm just saying, if you don't want to, don't waste your time. You don't have to. You never had to. X plus 3 plus x plus 2. If you solve that, realize it's on the bottom. The only thing that carries 2x plus 5 on the bottom on your answer choices is the choice B. Number 14. If 3x minus y is 12, what is the value of 8 to the x power over 2 to the y power? All right, so a lot of people get intimidated when they look at something like this, right? It's like, oh, like different coefficient, different exponent, oh my God, like what do I do, right? Okay, here's a tip about SAT. When you are stuck, right? When you have absolutely no idea how to do the problem, start from where you know how to do something. So if you look at this problem and you know how to do something, just start with that. And just let the flow just go with it until you realize something clicks and be like, oh, okay, like this is probably what I'm supposed to do, right? So 3x minus y, when do we see that? On systems of equations, right? But do we have two different equations that look something like this? Nope. So can I do anything with that? 3x minus y is equal to 12? No, I can't do anything with it. So I'm just going to leave it. Probably make a use of it later, but I just don't know what to do with it right now, right? So let's go ahead and look at this guy. 8 to the x power over 2 to the y power, okay? 8 to the x power over 2 to the y power. Since I can't do anything with that, I got to do something with this to start with, right? All right, let's take a look. Okay, well, I can't do anything because, well, first of all, the problem is the coefficients are different. But what if I can make the coefficients the same? How? I'm trying to see if there's any relationship between 2 and 8. Oh, 2 times 2 is 4. 4 times 2 is 8. So the top is 2 times 2 times 2, which is 2 cubed, right? So the top is 2 cubed. Do we all agree, right? Same thing, right? 8 is 2 cubed, right? Well, now I can multiply the exponents, so it becomes 2 to the 3x over 2 to the y. What do I do with the exponents when I have the same coefficient? That's right, we subtract them, right? So now this becomes 2 to the 3x minus y. All right, so far so good. That's all really I can do. That's literally everything I can do with this. Now I'm stuck again. Wait, am I really? Take a look, 3x minus y. Haven't we seen this somewhere? Over here, right? 3x minus y is 12. So aka this whole thing is just 12, right? So what is this now? 2 to the 12 power. Do I see this in my answer choice? Luckily I do. Choice A, right? So please, this problem looks super hard, but if you just start with whatever you know how to do in the problem, it'll just naturally lead you to the answer. So don't be intimidated. SAT problems are not designed to be that difficult anyway to begin with. Number 15, if ax plus 2 times bx plus 7 is equal to 15x squared plus cx plus 14 for all values of x, and a plus b is 8, what are the two possible values for c? Once again, the way I've been doing the questions, they say, what are the two possible values for c? And I'm looking at all these numbers that are different apparently, which means if I find one possible value for c, I'm just going to use that and circle my answer choice, right? So let's get started. So ax squared, or ax plus 2, I'm sorry, times bx plus 7 is equal to 15x squared plus cx plus 14. So that c is the middle term right here with the x on it, right? So, and what do they say? A plus b is 8. So it could be like 6 and 2, 4 and 4, but what do I know for sure? AX times BX, the whole foiling process, right? When I do the whole foiling thing, well, AX times BX will give me the first term. I mean, what gives me 15? 1 and 7? If, say, A and B are 1 and 7. 1 and 7, 1 times 7 will give me 7. 2 and 6, that'll give me 12. 3 and 5, that'll give me 15. Bam, there we go. A and B are 3 and 5. It could be the case that A is 3, or it could be the case that B is 3, right? I'm just going to test one and find one possible value and just answer my question, right? So let's just say, A is 3. So then it's going to be 3x plus 2 and 5x plus 7, right? All right. I would normally solve for the whole thing, the foiling thing, but once again, I'm only looking for the middle term, the cx, right? So I'm just going to go ahead and be like, okay, let me do that one, and that's 21x, right? And let me do that one, that's 10x. Add them. What do I get? 31x. That's supposed to be the middle term, aka cx, which means my c should be, 31. That's one possible value. Let's go ahead and see. That doesn't have 31. That doesn't have 31. That doesn't have 31. That has 31. My answer choice. Once again, I can go ahead and test the other one, right? I can make it 5x plus 2 and 3x plus 7. Because it could be vice versa. And that will be 35x over there. And that will be 6x over there. So you add them, you get 41x. You could have checked this. Or you could have just moved on and be like, okay, I don't want to do the whole problem because I know for sure 31 should be one of my possible values. And the choice D carries it. That's the only choice that carries it, right? So save yourself some time once again. Number 16, now we're on to the free response questions where we just fill in the numbers and bubbles, right? All right, so if t is greater than 0 and t squared minus 4 is equal to 0, what is the value of t? Easy, right? Just solve for it. T squared minus 4 is 0. Add 4 on both sides. T squared is equal to 4. Take a square root of both sides. T is equal to plus or minus 2. So either 2 or negative 2. But you guys realize in your free response bubble sheet, you cannot answer negative number on your SAT bubble sheet, right? So clearly this guy is out. And plus it says t is greater than 0. So negative 2 doesn't apply. 2 is my answer, right? Easy. All right, number 17. A summer camp counselor wants to find a length x in feet across a lake as represented in the sketch above. The lengths represented by AB, EB, BD, and CD on the sketch were determined to be 1,800 feet. Okay, let me just go ahead and mark it. So AB is 1,800, right there, 1,800. And EB is 1,400 feet. EB is 1,400. And BD is 700. And then CD is 800. So CD 800, okay, respectively. Segments AC and DE intersect at B. We see that. And AEB and CDB have the same measure. What is the value of x? Okay, so first of all, this is probably, I mean, what do you guys see? I was marking the picture, and I see the 1,400 and 700. I see that right off the bat. It's probably proportion problem, right? Let's just make sure, though. So, clearly we're given two triangles. And we know these two angles are equal. What else do we know the angles of? What about these guys, right? They're vertical angles, right? Because they're at the intersecting point, right? So, by the postulate of angle, the two triangles we know are for sure similar, right? So the big triangle is similar to the small triangle, right? So it's pretty easy then at that point. Clearly, 1,400 and 700, the bigger triangle is double the size of the smaller one, right? So what are we looking for? X is over here. If this is 800, what must that be? Probably, yeah, let's not do it. 1,600 feet. It's just double, right? So that's probably 900. That's probably 1,600. That's it. Easy. Such an easy problem. Number 18. x plus y is equal to negative 9, x plus 2y is equal to negative 25. According to the system of equations above, what is the value of x? Okay, there are two different ways to approach this. So once again, I'll do approach 1 and approach 2. Whatever you guys like, you guys go ahead and take it. And I'm just going to tell you earlier that I like the approach 2 because that's my approach. But we'll do it both ways, okay? So approach 1 is how you normally do it at school. So we're solving for x. So I have two equations in a system. So I want to cancel out the y to find out the x, right? So I'm just going to line them up. X plus y is equal to negative 9. X plus 2y is equal to negative 25. I want to cancel out the y's. So I'm going to multiply the top one by negative 2. Then I get negative 2x minus 2y is equal to positive 18. X plus 2y is this negative 25. They cancel. Negative x is equal to negative 7. So x is equal to 7. So there you go. That's your answer. 7 is your answer. Now here's another approach. Approach number 2. This is the way I like it. Because if you can do this, if you can think this, this problem becomes really fast. I'm not going to say 2 seconds, but maybe like 8 seconds top, right? Take a look. X plus y is negative 9. X plus 2y is negative 25. What just happened? This and this are literally the same equations, except that this is adding one more y, right? And what happened to the value? It went from negative 9 to negative 25, aka it went up by negative 16, or it went down by negative 16 for just adding one y, aka y is negative 16. What do? Plug it back in here, right? So x plus y is negative 9, but we just realized that adding one y added a negative 16 to it, so x plus negative 16, because y is negative 16, and you just add 16 on both sides, x is equal to 7. So if you just saw the fact that x plus y was negative 9, but then you add just one more y, but it added negative 16 to it, and you realize that y is negative 16, you could have plugged it back in here and get that x is equal to 7. Saving one step, this is 2-step. Whatever you guys like. If you're more comfortable with how you used to do homework at school, go ahead and stick with your own way. But I would highly recommend and encourage everybody to practice methods that are something like this, because trust me, if you practice these a lot, ultimately it's going to save you so much time for your SAT. Number 19. In a right triangle, one angle measures x degrees, where sine of x is equal to 4 over 5. What is cosine 90 minus x, right? So let's go ahead and draw the right triangle. They tell us that it's a right triangle. So let me just go ahead and draw the right triangle here. All right. And then, right triangle. They say one angle measures x. I don't know. X, okay. Where sine of x is 4 over 5. What's sine again? You guys remember? Stupid SOHCAHTOA? Yeah, right? The good old days of geometry, right? Or if you're still taking geometry. Sine, right? Sine is opposite over hypotenuse, aka opposite is 4 and hypotenuse is 5 based on the x, right? X is over here, the opposite is over here, that must be 4. And the hypotenuse over here, that must be 5, right? If you guys are familiar with the whole special triangle thing, this is probably 3, 4, 5 triangle, right? You can use Pythagorean theorem, right, to find that out too, right? Well, I'm not going to do it. What is cosine of 90 minus x? Let's think about that. 90 minus x, that sounds real confusing, but take a look. The triangle adds up to what? 180, of which that's a right angle, so that's 90. So let's subtract that off. We don't know what this angle is, so let's call that y, right? What do we know about x and y? They should add up to 90 degrees, right? Why? Because triangle adds up to 180. That's a 90. So those two must also be 90 together, right? So x plus y is equal to 90, right? Well, take a look. We're looking for 90 minus x. Subtract x on both sides like this. then we get y is equal to 90 minus x, right? I mean, that kind of makes sense, right? These both add up to 90. So if you subtract this guy, you get this guy, right? So 90 minus x should be y. Vice versa, 90 minus y should be x, right? So 90 minus x, what is that? Just essentially this, the other angle, right? I'm just going to call it y. You can call it z, whatever. But 90 minus x, this guy is pretty much just y over here, right? So we can just rename this as cosine of y. What is cosine of y? Okay, y is over here. Cosine, adjacent over hypotenuse, right? Adjacent is this guy over hypotenuse 5. 4 over 5. That's your answer. Easy. It looks super difficult because you'll be like, oh, cosine of 90 minus x. Oh my God, like I've never seen such a thing. Well, technically you have, right? All you have to do is just think through just a bit of a step to do this problem. All right, last question number 20. If a is equal to 5 radical 2 and 2a is equal to radical 2x, what is the value of x? Simple problem, right? So a is 5 rad 2, but 2a is equal to rad 2x. So let's just make that 2a instead of a, right? So a is equal to 5 radical 2. Well, let's make it 2a by multiplying 2 on both sides. So 2a is equal to 10 radical 2, right? And then I got that, so set it equal to that, right? So 2a is equal to radical 2x. Well, 2a is that, so I can replace it. And then what do? Square both sides to get rid of the square root. Now, this is where a lot of people make mistakes. You can either, well, I've seen people doing this, 20 times 2, because like 10 times 2 and radical 2 squared, so 2. I don't know how, but some people have done that. And I've also seen 10 times 2 where they did square that one but forgot to square that one. So please don't make mistakes like these, right? That would be 10 squared and radical 2 squared, and that'll just be 2x over here. So that's 100 times 2 is equal to 2x. Cancel the 2's on both sides. X is equal to 100. Easy. All right, so that was the practice test 1 from CollegeBoard, section 3, the no calculator math section. And I will see you guys on the next one, which will be the CollegeBoard practice test 1, section 4, calculator allowed math section.